Video in our series for linear regression. If you've not yet watched video 1, go back and do that before you go ahead and watch this video. So we know that for linear regression we have several different goals that we're interested in meeting, and this particular video is going to focus on goal number 1, and that is estimating an equation that's going to describe our linear relationship between the dependent and independent variables. So if we remember back to video 1, we have our simple linear regression model here in which we've got our intercept, our slope, and our error or residual. And in order to develop this equation of interest, we need to figure out what the intercept and the slope are of our best fit line. And we're going to make a slight change in our model here because we're just interested in estimating the line. So for our respective line, we're taking out the error term because it will just be one straight line. And then also what you're going to note here is that we're switching from Greek letters to Roman letters. And this is because we're going to be using data from our sample, again, to infer information about our respective population. And this y hat component of our respective model, again, is indicating the estimated value of y based on the regression line and the value of x that we're interested in. So let's look at this example again of the length of our predators and the weight of their respective prey. So we have our respective best fit line here, and our equation for that best fit line is y hat equals a plus bx. Again, a being the y-intercept, b being the slope. And what we can do is we can take any given value of x, which is our independent variable, and we can use our formula to estimate what our y value should be based on our data, and that y value is going to be y hat. We can then compare that to our actual y value for that data point. And again, the difference here is going to be our residual, that error value of the difference between our actual value and the predicted value based on the regression model. So in thinking about our linear regression model, that best fit line indicates that it's going to appropriately describe the data that we have, and the goal is going to be to minimize the difference between the actual y values and the predicted y values. And this is the concept of using the least squares method. And this in turn is minimizing the sum of the squared errors, as we've talked about in previous videos. So what do we need to do in order to generate this equation? Well, we need to determine both the slope and the y-intercept of our respective data set. And so first we need to calculate the slope. And so in order to do so, we've got two separate formulas, both of which look a little bit scary, but are not too scary, as we'll see in some examples that we'll cover in Excel. But similar to correlation, you'll want to be comfortable in using both of these equations, and also what you'll find is that these equations are equivalent, in that we can use either one in which to calculate the slope. But as we're moving forward in class and you're working on the examples, I would strongly recommend using both of these equations to get comfortable using them in the event that one may be faster than another based on the data that you're given. Okay, so let's use our equations in which to calculate the slope of a linear regression model. So we have some raw data here on salinity and total length, and we're interested if the total length of our respective animals changes with salinity. And so in good practice, the first thing that we should do is plot our data. And what we see here is it looks like there's a relationship in that as our salinity values increase, as we move from left to right on this plot, we tend to see an increase in the size of our organisms. And in Excel, you can very easily generate the best fit line and get the regression equation. But for our respective course, one of the keys is going to be to learn how to actually calculate these values. So when you are taking some type of an assessment, like an exam, you'll need to show all the steps that you're taking in which to get these values. And so just providing this information will not get you full credit for a respective answer. So let's go to our data and let's look at our first slope equation. So if we look here, there's a variety of things that we need to calculate before we can actually calculate the slope. So we need to calculate out the summations of x, the summations of y, the summations of x squared, and the summations of xy. And so the first step is going to be to calculate out xy to fill in this portion of the formula and to calculate x squared. So we can then calculate this portion of the formula. So you can go ahead and do so. And then after this, we're going to take the summations that we need to in order to fill in our respective formulas. So we need to take the summation of x. So x again is going to be our independent variable. It's going to be salinity in this particular case. We need the summation of y. This is going to be the summation of our total lengths. We need the summation of xy. We just calculated those xy's. We need the summation of x squared. And then here, importantly, following orders of operations, we need to take the sum of x and then square it. So we can go through and we can take the summations of each one of our respective columns, and what you'll notice in this spreadsheet is that it gives you the formulas in which to do so, summations of each one of these respective columns, and then it's just a matter of calculating the numerator and the denominator by filling in the appropriate values. Now, one important key here is we've got n, and this small n, just like in correlation, refers to the number of data pairs, not the total number of data points. So in this particular case, we've got 10 different data pairs, so our sample size is going to be n. So we can go through and we can calculate the numerator, again, filling in the appropriate information here with the summations and following orders of operations. And then we can go through and we can calculate the denominator, again, filling in the appropriate information. And then once we've got the numerator and the denominator calculated, we can then go through and calculate the slope by dividing the numerator by the denominator. And we get our slope of about 1.4. So this means for every part per thousand salinity that we increase, the size of our animals tends to increase in that realm. Now, let's use the other formula in which to calculate the slope as well, because maybe this is a formula that you prefer, or maybe you're going to be given information in a question that's going to make this formula a little bit more effective. So if we look at this respective formula, we're looking at the differences between the actual data points and the means of those data points. And so xi minus x bar, yi minus y bar. So the first step that we need to do is to calculate the means of our respective data, both for salinity and total length, our x's and our y's. So we can go through and we can calculate those means, and again, you can use a formula in Excel or you can do this in your calculator. The next step is going to be to calculate our respective differences between our x values and the mean of x, and the difference between our y values and the mean of y. So we're going to need to do that for the numerator and for the denominator. So we can go through and we can calculate those out. Again, you can use formulas if you'd like, or you can do this by hand. And then it's just a matter of going through and calculating the numerator and the denominator. Now, one important step here is that we need to follow orders of operations. So for the numerator, we're going to need to multiply those differences by one another before we take the summation. And then for the denominator, we're going to need to take the square of the difference between the x values and the mean before we take the summation. So we can go through and we can calculate out these respective steps here. Again, noting that we've got squared values for our differences between x and x bar, and then here we're multiplying the values for these two columns. After we've done that, we can then take the summation of each one of these columns here, and this is going to give us the values for our numerator and for our denominator. And what you'll notice is that these values are exactly the same as for the previous formula, and this then gives us the slope of our respective regression line. So after we calculate our slope, our next step is going to be to calculate the y-intercept. And to do so, we're going to use the following equation, which is much simpler than the equations for the slope. The mean of y minus the slope times the mean of x. Now we're not going to go through examples in the video. We'll go through a couple examples in class, but this formula is relatively simple compared to many of the others that we've used, and I feel comfortable that everyone can calculate the mean of y and the mean of x and use this formula after you've calculated what the slope of our regression line is. And for more information on this, you'll want to check out section 14.3 of the text. So now that we know how to generate that equation for our linear regression model, the next video is going to focus on using that equation to make predictions based on that regression model, and then to estimate how much variability we have in the dependent variable that's attributed to the independent variable.